What does it really mean for an AI to think? Today, we're diving deep into two architectures: AI automation versus AI agents. Traditional automation systems execute predefined procedures with predictable inputs and expected outcomes. AI agents operate differently by pursuing objectives and adapting behavior when conditions change unexpectedly. In 2026, most organizations have already optimized automation opportunities, creating diminishing marginal returns. Agentic systems unlock broader value by handling ambiguity, reasoning through exceptions, and adapting dynamically to new environments. But here's where it gets interesting: the automation ceiling. Every exception breaks the script. Rule-based systems perform well only when reality closely matches predefined assumptions. Every unexpected input, policy change, or process variation introduces new maintenance requirements. Human operators often become escalation endpoints, limiting scalability and operational efficiency. As workflow complexity grows, maintaining thousands of rules becomes more expensive than the work being automated. So, what's the real problem? Let's talk about why rules fail. Deterministic systems versus probabilistic reality. Traditional automation assumes predictable schemas, stable business processes, and clearly defined decision paths. Real-world environments contain ambiguity, incomplete information, and constantly changing requirements. Organizations often attempt to solve complexities by adding more rules and conditional branches. This creates exponential growth in maintenance burden while still failing to capture human-level judgment. This raises a critical question: the breakthrough. Goal-directed foundation models. Modern foundation models combine reasoning, planning, tool use, and contextual understanding in a single system. Instead of following predefined scripts, agents translate objectives into executable action plans. Dynamic task decomposition allows workflows to adapt in real time as new information emerges. Reliability improves through validation loops, self-checking mechanisms, and iterative refinement strategies. Now, let's zoom in on Agentic system architecture. Orchestration over scripting. Agentic systems are built around continuous interaction between goals, reasoning loops, and external environments. Perception layers gather information from users, systems, and real-world signals. Reasoning layers evaluate options, prioritize actions, and determine execution strategies. Human oversight remains essential, but operates at governance boundaries rather than inside every workflow step. Here's something most people overlook: core components. Building blocks of capable agents. Memory enables agents to retain context, learn from previous interactions, and maintain continuity over time. Tool integrations expand capabilities beyond language generation into execution and decision support. Planning modules break large objectives into manageable subtasks with clear dependencies. Orchestration systems coordinate retries, escalation paths, prioritization rules, and resource allocation policies. Think about this for a second. Workflow in production. From task to goal, the execution path. Every workflow begins with a goal rather than a fixed sequence of instructions. Agents continuously cycle through observation, reasoning, execution, and evaluation phases. When failures occur, the system replans using updated context instead of terminating immediately. Successful outcomes are recorded to memory, improving future decision quality and execution efficiency. And this is where things get complex. Measurable impact. Adaptability becomes a KPI. Organizations report significantly higher automation coverage when agents handle exceptions autonomously. Maintenance requirements decrease because workflows no longer depend on manually updated decision trees. Confidence-based execution allows routine cases to proceed without constant human intervention. Human workers shift toward defining objectives, policies, and success criteria instead of resolving exceptions. But here's where it gets interesting. Future trajectory. Multi-agent swarms plus verifiable reasoning. Future systems will consist of specialized agents collaborating across complex business workflows. Individual agents will focus on planning, analysis, execution, compliance, or verification tasks. Formal validation layers will ensure safety and reliability for high-impact decisions. Human agent collaboration will evolve into the dominant operating model across knowledge-intensive industries. So what's the real problem? Let's talk about decision framework. Automate versus agent, when to use which. Automation remains ideal for highly structured, repetitive, and predictable processes. Agents excel in environments characterized by uncertainty, variability, and changing objectives. Organizations should evaluate exception frequency, reasoning requirements, and process volatility. The most effective architectures combine deterministic automation with agentic decision-making layers. This raises a critical question: production readiness. Running agents at scale 2026. Production-grade agents require observability, governance, and performance optimization from day one. Every reasoning step should be traceable through logs, metrics, and execution histories. Cost controls, latency limits, and safety guardrails are critical operational requirements. Successful deployments balance autonomy with accountability through structured oversight mechanisms. Now let's zoom in on strategic imperative. Build for goals, not scripts. Automation should be viewed as one capability inside a broader agentic architecture. Competitive advantage increasingly comes from adaptability rather than procedural efficiency alone. Organizations should prioritize investments in memory, orchestration, tooling, and evaluation infrastructure. The strategic question for 2026 is no longer whether agents will be adopted, but how quickly they can be deployed responsibly.